Everyone keeps hearing that humans are going back to the moon, but what most people miss is that this isn't one mission. It's a sequence of missions building on each other, and Artemis IV only makes sense if you understand what came before it. The whole program, led by NASA, is designed step by step, almost like testing layers of a system before actually committing to long-term lunar operations. It started with Artemis I, which was essentially a full test of the system without humans. NASA launched the Orion spacecraft using the Space Launch System, sent it all the way around the moon, and brought it back to Earth. The goal here wasn't landing. It was proving that Orion could survive deep space, handle navigation, and most importantly, survive re-entry at extremely high speeds. Artemis I was basically asking one question: can this system even work safely without humans? Then comes Artemis II, which takes the next logical step, putting humans into that same system. This mission doesn't land on the moon either. Instead, astronauts fly around the moon and return. It's about validating life support systems, crew safety, and real human performance in deep space. Up until this point, everything is still preparation. NASA is reducing risk step by step instead of jumping straight into a landing. Artemis III is where things start to shift. This is planned to be the first mission that actually lands humans on the moon since Apollo 17. But even here, the architecture is different from Apollo. Instead of one spacecraft doing everything, Artemis III introduces the human landing system, likely the SpaceX Starship HLS. Astronauts travel to lunar orbit in Orion, dock with the lander, descend to the surface, and then return. So Artemis III proves that this new multi-vehicle system actually works for landing. Now this is where Artemis IV becomes important, because it's not just repeating Artemis III, it's expanding it. By the time Artemis IV happens, the goal is no longer just landing, but starting to build a sustainable presence. This mission is expected to support the early assembly of the Lunar Gateway Station, which will act like a staging point in orbit around the moon. So now you're not just sending a lander and coming back, you're beginning to create infrastructure in space. The complexity of Artemis IV comes from how many moving parts are involved. Just like Artemis III, the human landing system, again, something like Starship, has to be launched separately, refueled in orbit, and sent to lunar orbit ahead of time. Then the crew launches later aboard Orion using SLS. After traveling for about 3 to 4 days, Orion enters a very specific orbit called near rectilinear halo orbit. This orbit is critical because it's stable, fuel-efficient, and ideal for long-term operations, especially with the Gateway Station. Once in orbit, Orion has to dock with the lander. This might sound routine, but doing this around the moon is significantly harder than in Earth orbit. There's less gravitational stability, communication delays, and fewer correction opportunities. After docking, 2 astronauts transfer into the lander while the other 2 remain in Orion as a backup. That redundancy is intentional. It's about safety and mission reliability. The lander then separates and begins its descent toward the moon's south pole. This location is chosen very deliberately. Unlike the Apollo missions, which landed near the equator, the South Pole has regions that are permanently shadowed, and these areas are believed to contain water ice. That changes everything. Water means oxygen, fuel, and sustainability. So Artemis IV isn't just landing for exploration, it's landing in a place that could support future human presence. Once on the surface, astronauts will spend several days conducting EVAs, collecting samples, and testing new technologies. These aren't just scientific experiments, they're practical tests for future missions. Things like mobility systems, resource extraction, and surface operations are all being evaluated to answer one big question: can humans actually operate here long-term? After completing surface operations, the ascent stage of the lander launches back into lunar orbit and docks again with Orion. The crew transfers back, leaves the lander behind, and begins the journey back to Earth. Re-entry is one of the most intense phases, with Orion hitting Earth's atmosphere at around 11 kilometers per second, generating extreme heat that the heat shield has to withstand. Finally, the capsule splashes down, completing the mission. So when people talk about Artemis IV, they usually frame it as another moon landing. But that's not really what it is. Artemis I proved the system works. Artemis II proves humans can safely travel in it. Artemis III proves we can land again. But Artemis IV is where things start to shift from exploration to expansion. It's the point where we stop treating the moon like a destination and start treating it like a place we can actually work, operate, and eventually stay.